Okay, now
We're up to 1,000.
yeah, Hey, this is Tim here. I hope you're keeping well. I'm in the mood to redo this DC motor video I did a while back. I have Jacob Yarnell beside me here, and he's a really good student of mine, and he's helping me out. So you're looking at all the parts you need to actually build this DC motor. Jacob, why don't you start with that base? What's going on with that?
So you're going to start off with some regular 2x4s and regular 3/4 inch plywood. It's going to be 3.5 inches long and 9 inches long, 3.5 inches wide.
Yep.
The 2x4 is going to be, since it's a standard 2x4, the length is already set, and then it's going to be 4 3/4 inches tall.
Yep.
And then you're going to drill 2 holes, 1 hole in each 2x4. That's going to be with a spade bit, usually 7/8 of an inch or 0.875. It's going to be 1 1/2 down and 1.75 over.
So this, you know, in Europe and Mongolia, the rest of the world, they don't have, I'm not even sure, I don't think they've got 2x4s, but essentially this is just a platform, and you could convert this into centimeters and it would work just fine. So you're gonna drill a hole. You're gonna have to draw a line that's centered in this 3.5, which is 1 3/4. You're going to draw a line all the way up, and then you're going to come down 1.5 inches. Now, this white tube here, let me just show you that really quickly. Do I have it flipped the wrong way? I do. We got this from not McMaster-Carr, we got it from Home Depot, and this is just a piece of 3/4 inch water pipe, isn't that right?
Yes.
So it's just 3/4 inch water pipe. The thing about this, the outer diameter of that is roughly 0.9 of an inch, right? So you're going to get your 0.875 or your 0.9 spade bit drilled through here. The important thing is that these 2 holes are concentric, because why? They're acting like bearings. So forgive me if this camera is a little bit shaky. All right, and that just goes through there, and that's just acting as a simple bearing, cheap, and it does the job. Now, the length of the pipe, this white pipe, is roughly 2 inches, isn't that right?
Yes.
And how are you keeping that in place, Jacob?
You're going to hot glue it. You can put hot glue around the pipe and then slide it in, and then put more around each of the edges.
Yeah.
Just to make sure that it holds itself
So
in.
show them an out picture of the hot glue gun we have. This is high tech right here.
Yeah, it's just the standard hot glue gun.
Okay. And that does the job.
It does.
Does the job. So, also, this is a 1/2 inch water pipe that Jacob has given me here. So again, I'll flip it round. There you go there. Snake bite again. That's a 1/2 inch inner diameter, and I think it's like 0.65, and it fits, if I could actually do this, but it fits in there. They get the idea. Now, what else are you going to need for this setup? You're going to need
some just generic electrical tape.
Yep.
That'll work for anything.
I'm sorry, Jacob, I wanted to tell him something. My brain, it's 9 o'clock in the morning, my brain is all over the place. You're going to use a typical wood saw to cut the 2x4. If you have, is it called a chop saw really? Or not a bandsaw?
Yeah, you could use a bandsaw.
You could use a bandsaw, but just a simple hand saw would even work. You're going to use a hacksaw for the pipe though. I would say the hacksaw would be the best for the water pipe. Now, sorry, go ahead there, Jacob. What is the length of that? That's a 1/4 20 threaded. Okay, now any sort of threaded, all we're using it is really as a bolt. It's holding the
4.5 inches.
4.5 inches, and then we have nuts that will screw onto it. We'll explain that later. I'm after getting these magnets from Radio Shack. They're closed now, but these are really strong magnets. And you can see I have a little compass there, and look, that will help us with the magnetic direction. If you have one of these, that's good too. It's a good thing to have. You can get away with not having one. You're going to need a soldering iron, so a cheap one will do, but we have a nice Weller one. You're going to need magnet wire. What is this? This is 26 gauge magnet wire, and it's pretty thin. You might be able to get away with, what other, Jacob, would you mind, what other magnet wire do we have over there? Is that 26 as well?
Yes, I believe so.
So we have another roll of it there. We got that from McMaster-Carr. What's this one here?
30.
30. So the 30 AWG magnet wire is a lot finer. Believe it or not, I found the finer the wire, the stronger the magnetic field, but you're going to do a lot more turns. What else? You're going to need a lighter or matches. I'll explain that later. You're going to need washers. Jacob, will you find out what the inner and outer diameter of those washers are? Paper clips, super glue, Loctite. Basically, the washers. Basically, the washers need to go outside of the pipe. So the outer diameter is what?
The inner diameter is 0.675.
Inner diameter is 0.675.
The outer diameter is 1.25.
1.25. Any washer that's somewhat close to that will do the job. It basically has to slip over the pipe. Now, we have these brackets, and you said they're 2 inches by 2 inches. They're going to hold the magnets in place. Paper clips. We got these in Home Depot, and you'll see them. They're used for screwing a pipe up against a wall. The nice thing about these are, I think they're pure copper. I've seen the same type of gizmo, and it maybe has copper plated. Okay, but you want if you can get one that is pure copper, that's what you want. It's going to be. I wonder, is that really? That's hardly 100% copper, but anyway, you'll see. We're going to use that for the commutator. Okay, so step number one, what you want to do is get your 2x4 and get your base working, and you want to construct this. And the next thing you're going to do is you're going to get get your base. You're going to screw the plywood to the 2x4s with any sort of wood screw will do the job here, and you've created yourself a little structure. Okay? Right, once you have the base done, we need to drill a hole in this pipe. We need to drill a hole that this bolt will fit through, and it's going to sit something like that. The rough dimensions of this pipe are a little over 12 inches. Jacob is going to come over 5 inches from one end, and he's going to drill a really small hole all the way through the center of it. He's going to set up a vise. Now, we're going to use this vise here, okay? So we have the pipe in the vise. Jacob has marked 5 inches from the end, and he has his little mark. He's going to use a little screw gun with a very small drill bit, and he's going to go straight through it. This is a little bit tricky. Look at that, no messing. So go through the small drill bit, and then step it up to a 1/4 of an inch. Right, and what you're going to do now, you're going to put that through your hole, and you're going to hold it from either side of the two nuts.
It's not big enough.
It's not big enough. Alright, so yeah, get yourself a bigger.
0.287.
Yeah, that'll work. Is there 0.265 there?
Yeah, let's try that.
Try that one. Jeepers, huh? I wonder, is it bigger? Why don't you put? Will you do me a favour and put a calipers on that thread and see what the hell is wrong? Maybe I'm. Bet just 0.312. 0.33125. So that guy there is a 5/16 threaded rod. It really doesn't matter what size. So something bigger than a 1/4 of an inch. Yeah. The important thing, Jacob, is don't listen to me. There you go. yeah.
Got one nut on it still.
Yeah, exactly.
To hold it.
Yeah, you got it.
And you basically just try and center it. Try that.
You got it, yeah. Now, you can take that out of there for a sec. I think we're done with this vise.
Yes, we are. I gotta take this.
All right. Yeah. See, that's the thing. That's a step.
So I took it out again.
Yep.
Because you gotta slide it through and put it back on.
Give it a little spin. Beautiful. Now, go ahead.
All right. So the next step that we're gonna do is, you see how it can move back and forth this way. We're just gonna put 2 washers on the ends and glue them, just so that stops it from doing that.
Yeah, and I'm thinking, you want.
About an inch in, maybe.
Yeah, I don't think there's any harm in having those washers actually touch from one side the white bearing. I think that will work just fine. So what you want to do here is, what is the he's after tightening these 2 nuts. What is this distance approximately? It's about 1.5 inches from there to there. Okay, so do you want to get the ruler out and try it out? Bowie State College. Make it 2 inches, Jacob. There you go, 100%. Yeah. So, how's our glue gun looking?
Well, we just plugged it in, so we probably got another couple minutes.
Yeah, it's not doing anything.
Yeah. 2 inches in.
Mm-hmm. Do you want me to hold? I can hold this shaft here for you.
Shaft. And then
Yeah, just
try to wrap the glue
that's
around.
all you're doing. Yep. Guys, no swearing now. I'm trying to make a video. If you're going to swear, do it after the video. Sorry.
That's good.
Made in America. Alright, so let's let that cool for 2 secs. And that should... Okay, that's nice.
Should lock it in.
That should
so
pretty
it's
much
not
lock it
going
in.
anywhere.
Yeah, yeah. Now, okay, what's next? Okay, yeah, okay. Alright. There might be a better way of doing this. And people would probably say, well, why don't you wrap the wire before you install it? But I for whatever reason, I don't think you can do that right now. So what you're going to do is you're going to have your magnet wire. And what I'm doing is I'm putting that down on the deck. So I have a lot of it. And what I'm going to do is I'm going to give myself an awful lot of room here. I'm just going to tape a little bit of it on. Oh, sorry about this now. Here we go. So let's just tape that there and act like a third hand, just holding it in place. And what I'm going to do now, I'm going to go from the very, very bottom, and I'm going to go round and round and round and round. I'm going in one direction here, round and round. I try and keep them a lot. The neater and the more you can pack them in, the better. And so I'm just going to keep going. So you may as well turn that video off now. Yeah, is it good?
Yes.
So the important thing is to keep rotating the wire in the same direction. I don't crisscross and go. They absolutely have to go round in the same direction. If you start going in an opposite direction halfway through, you're going to cancel out your electromagnet that you're doing. Now I'm going up one side of the shaft and I'm going down. Oh my god, what a pain. You need to, how many, some people is going to ask how many turns. Just keep on going until your wrist hurts. You're going to do, the more you can do the better. Just keep on going. Round and round, and now I'm going to go back up. Okay, you can stop that now. You sure it's recording, yeah?
Yes.
Good man. So what I'm going to do now, I remember that it's going round in this direction. I have to be careful. So let's get a bit of tape. Alright, it's going round in this direction, and my instinct is to get this over here and start going round there as well, so I'm going in the right direction. I'm just going to hold that there, and I'm just going to use this tape just to, it's going to hold that wire in place, so it's not going to easily come off. Your electrical tape is not going to do anything to the power of the magnet, the electromagnet, not one bit. So let's, oh my god. So now, the main thing is, what's the important thing, Jacob?
Keep going in the same direction.
That's it, or you're literally wasting your time.
If you don't go in the same direction.
Exactly. That's it, you can turn that off. It's on?
Yep.
So it's important that you try and keep the number of turns to the same number of turns. This is very, very hard because it's mind-numbingly boring winding it. I'm just looking at this to make sure they're quite close. What am I going to do now?
You're going to tape the end of it.
Tape the end of it, exactly, yeah. Keep the kind of wire, makes it easier to keep the wire in place. If it rotates, it's going to, it probably could unspool, okay? And you can put more tape in there now. What I'm going to do here is I'm going to wind, I need to snips, don't I? So stay there for 1 sec. Now what I'm going to do is I'm going to be generous and give myself nearly a foot. And now I'm going to take the magnet wire away, and you can stop that wheel.
Alright, you're on.
So what we're going to do now is we're going to create a split ring commutator. Now you can look that up on YouTube. I couldn't be bothered trying explaining it. But we're going to make a split ring commutator here, and I'm using the pieces of copper that I got from Home Depot. I'm going to measure them, and let's have a look. How long do I want this to be? Roughly, let's make it 0.75, and I'm using the calipers, 3/4 of an inch. And I'm just going to score this, and then I'll mark it with my Sharpie, and I'll do the same here. 3/4 of an inch. This can be, you can be, try and be as accurate as you want, but it doesn't, it's not, it can be so close to 3/4 of an inch is what I'm trying to say. This is my trusty, what the hell is this thing called again?
It's a bolt cutter, isn't it?
Bolt cutters. And it makes life easy. You could use a hacksaw to do this. Okay? And what it will do is it will, see that? What's that called? Is it called scoring? I'm not sure. And then,
Like a pressure cut.
yeah, it's like pinching it. Now, is that too big or that too small? That's about right. Maybe a little bit bigger. And what that'll do is that will sit there. Now we're gonna have to make that. We're gonna have to bend that round to make it more cylindrical. Will that fit on there? Yeah, that's pretty good. But I'm gonna have to bend that and make that more cylindrical. And let's do the other one. Hacksaw might work. Maybe make it a little bit longer than 3/4. Alright, we have this. Now, what do I need? I'm going to get a wrench. And I'm going to just try and just form this and make this more cylindrical that will wrap around the pipe. Alright, I'll just test it there. You know, so you see that? Too fast? Yeah, that's starting to look good, and that fits. That's pretty good there. So do you see that? Okay. Okay. That'll do the job. Okay.
Yeah, the whole point is for them not to touch, right?
The whole beautiful is for them not to touch or it will short. So what we're going to do is I'm going to set my my shaft at 12 and 6 o'clock, and I'm going to put these split rings opposite it, like so. What I'm going to do before that though is I'm going to widen out. I'm going to take a bit of tape and kind of lock these wires down here. When you're using electrical tape, you should always have keep a bit of tension on this, and you'll be able to wrap it a lot better. Now we have this, and what I'm going to do is I'm going to widen out. Taking a long piece of tape, and I'm going to widen out this shaft here. I'm going to make it a little bit wider. I'm going round and round and round. For whatever reason, I found I got better results if I had a bigger circle here, if it was slightly wider. I can remember that. So that's going to sit roughly there. Now I need some way of connecting one wire to one plate of the commutator, and I need to connect the other wire to the other plate. So what I'm going to do is, let's turn on this soldering iron. Like that. And what I'm going to do is I'm going to get some solder. Sorry, Jacob, I'll just get my hand there. So I'm going to set this to like 700 Celsius or 700 Fahrenheit, whatever it is. It looks like it's Fahrenheit. And what I'm going to do is I'm going to snip this roughly around there, and I'm going to show you how to connect this wire to that commutator. First thing you want to do is, this has a protective, I don't know, is it nylon? I don't know what it is. It's a film on it that even though this looks like it's copper, this is not conductive. There is an insulator around it. If you burn this insulator, I'm not sure if it gives off toxic fumes or not. So what you can do is if you don't have a lighter, you need to scratch. Now, the problem is you're going to cut it if you do this. So look, I'm just going to do this. Close your mouth, Jacob, right? Alright, that does the job, okay? Do you see that? Now, I don't know if you'd want to be burning lots of that, but that's a much easier way of, actually, now you can see it's clean now. Did you see that?
Yeah.
Okay. So this thing is still heating up. I'm going to take this side, cut it. I don't think you're going to have any, look, I should, you don't want to be breathing in toxic fumes, so we have a nice airflow here. I'm just doing it for a few seconds. Okay. And then you want to clean it off. We want a good electrical connection between the copper commutator and what, instead of using the sharp bit, maybe I just use these rough bits and I try and rough this up a little bit. And actually, if you look closely, you can actually see a real copper wire. You could use sandpaper for that. I think you'd be doing it for a while. Right, I'm going to see. Now watch this. So I'm going to connect one. So I have my solder. Now it takes a lot of heat to get. You'll see what I'm looking for.
And then you're tending the commutator.
Yes. Now you can see there that the solder, the copper is not accepting the solder. I'm holding that up against the copper, and there it is. Okay, that's what you're looking for. And then I feed it in a little bit more. Now I get the wire, and I'm trying to pull it over. There you go. I'm also burning my finger a little bit. So I can't talk at the same time. What did I just do there? I'm making the solder flow. Once I see it flowing, I get my wire in there and I'm blowing on it. I can't talk at the same time. I'm trying to get it to turn into a solid, okay? I would keep that away from your fingers because it's going to burn them. Now we get the next one. I'm pressing against the copper. I want a good heat transfer between the solder iron and the copper. And I'm feeding the solder and kissing up against the side of the soldering iron. Okay, and I'm going to feed it a little bit more, and then I'm going to get this guy. And I'm kind of getting it to flow above the wire. There she is. That's it. So I've just made 2 electrical connections from the wire to the copper. Jeez, that was hard work. Now I get the super glue, and I think I've other better super glue here. The thing about super glue is, if you open some, I feel like it goes off. Right, what am I going to do now? Set this lad to 12 and 6 o'clock. I'm going to have to cut the end of it. It's not my day today, is it?
Did you puncture the aluminum on top?
Oh yeah. Is this like old school or what? Is it very old? Yeah, this is solid. When we use hot glue to do this, yeah. Damn it, anyway. Yeah, we'll just use hot glue. You can turn that off. Glue gun. Maybe we'll do the job. Now, I set this at 12 and 6. And your split ring commutator, if I look at it from this side, yeah, that's a massive gap. This gap should not be we can try it anyway, but this gap is very, very big. It should be a little bit less. Could I take away the tape and make that smaller? Maybe let's try that. Make the diameter of the shaft smaller. And honestly, at this stage, I don't know whether which side goes on what. I have to be honest with you, it's just trial and error. So we'll be honest with you in the video if we have to redo stuff. We haven't done this in a while. I get a bit of hot glue on there. Oh, you nasty. Hot glue is good because it kind of holds it in place. It doesn't have a whole lot of strength. It'll hold it in place, and it's just the right amount of strength we need for this project. It's not, if we have to remove them, it's not the end of the world. And redo it. All right. Ah. That gap is way too big, but we're kind of hoping that the inertia of the spinning will get us past it, you know what I mean? So I'll believe that when I see it. And what I'm going to have to do here is this is, let me just, there you go. Alright, we're just going to leave these here. We can tape them up if it works. I'm not going to bother taping all that down. That's that. So basically power is, okay, what we're going to do here is we've gotten just a couple of screws. Have you got a big, let's use this guy. Couple of screws, a couple of washers, and what this section, this is kind of easy. These are our high-tech brushes. Now what the brushes do, you see this? Look at that. That's not going to work. We need bigger or longer. No, hold on. Let's not give up that easy. Okay, that'll do. Just getting stressed out there. So it's going to be something like that. And this will do the job for the brush quite easily. You'll be able to position them. So it'll sit something like that, and then on the other side. Now, what we're going to do is these are our electromagnets. We need to have permanent magnets that sit roughly there. So what you should probably do, and this is going to be trial and error as well, I'm going to get two magnets, and I'm going to stick them on there like that. And this needs to come out ever so slightly, and it's like that. Whoops, I'm going to tape this on now. So I'm going to make sure these are going in the same direction, and that will come over there. So there's a magnetic field going across, and I'm going to put that on there like that. So these lads will connect like so, and I'm putting them on the top. Magnets are very, very brittle, so you don't want them to be banging them up against each other. The stronger magnets you have, if you open up a hard disk, there's some very, very strong magnets in an old broken hard disk. Not these new solid state ones, but the actual motorized ones, if that's what you call them. Okay. Now I'm going to do something like this. Now let's get one. Okay. Now I need a screw here, and I'm going to. Oh. I'm going to position that screw there like that. Thanks for that. That is one crappy screw there, hold on. Let's get a better screw.
I was looking at the submissions to see what I did submit.
Yep. You can turn that off. So just tell me when you're going?
You're going.
Okay. So what am I doing here? I need to position the permanent magnets. Don't be like me and use screws that are too long and go through the 3/4 inch plywood. Get screws that are a little bit shorter. So space this out. Alright?
It's about 1/4 of an inch away from the poles.
Bloody hell, look at this. Look at this. Oh, it just barely catches. Oh, that's good. Okay, I thought. Move those guys out of the way. This is really a two-person job, isn't it?
It is.
I apologise, my original video was a disaster, I think. So that's perfect, okay? and we come all the way over here, and let's pull it out a little bit, and let's get another screw. Yeah, you got it. Yeah, good man. Now be a good screw and get in there. Go on, you can do it. Yes! Okay, now let me just make sure they're in there. See those magnets, I can... Alright, that's good. Okay, just like that. Right, now, we're nearly there. Okay. Do you want to turn that off for a second?
Go ahead.
So I had to dig up another paper clip, and they're acting as our brushes. And I'm going to be honest, we don't want... You're just going to see whether this thing works or not right off the get-go. So we'll see. I'm moving this over here, and I'm trying to position those brushes. Do you see? Now, I need to have constant tension. I need those. How can I do that? Can I give this? There we go.
Could you cross over?
And what I'm going to do is I'm putting a little bit of tension on this guy, so naturally, I'm just giving like a bit of spring action. And now, it's not going to be pretty, but it might work. We have a power supply. I can't see a power on this with a battery, to be honest with you. A 9-volt battery. I could be wrong. I think you're going to drain the current very, very quickly. I'm going to put one connection on one side. I'm going to put another connection on another side. And so let me ask you this. Before we power this up, let's go over what we just did. All right? And so the base, you're going to make the base. What's the important thing with the base is that both holes are concentric. So you take your time with the drilling. You're going to use a spade bit. Then you're going to drill a hole in this. This is a 1/2 inch water pipe. The white bearing is 3/4 of a water pipe. What did you do? You made this 5 inches?
Yes.
And then you glued, you drilled the hole. You put the metal, it was a 5/16 threaded rod. You tighten up the nuts on either side to hold it in place. You glued the washers in place. And then we started wiring. We made sure that every coil was going in the same direction all the way down. And then we taped them in place. We got, this gap here is too big, but this is our split ring commutator. And I have a feeling we're going to have to rip this, pull this off and make them slightly closer, which is not the end of the world. We soldered the underside. We had to strip the insulation off the magnet wire. And we have these magnets here, okay? And I'm pretty sure the magnets are going in the same direction. So let's turn this on. So we're going to turn the current up full blast. This is a current limiting power supply. I'm going to turn the voltage all the way down, and I'm going to turn it on. That's a good sign. I'm going to turn the voltage up, say, to about 7 volts, and I'm going to turn it. And believe it or not, that was our first go. So that's a very, very good sign. Okay, so you can turn that off. We can fix it. Yeah. So I'm actually amazed that it worked the first time. Before I've had to move the position of this commutator, I might have had to adjust the angle of it. So the split in the commutator lines up with this top pole. Okay, this split is way too wide. It could be 1/8 of an inch. One other thing you want to watch out for is in this situation here. I don't know if you can see it, but you would have a short. And one way around that is if you take one of the commutators and you kick one of the edges out, and it stops it from shorting, if that makes sense. So this bottom one, we could kick it out a little bit, But let's run this bad boy and see it spark. I'm going to get an old tachometer. We'll see. So we're running this at 7 volts, and I see. I'm sure there's some shorting going on. Nice bit of torque on it as well. So what we did is we put a little bit of this tachometer tape, shiny tape, on the shaft, and look, what could you do to improve this? I don't think having 4 poles is a good idea. 2 poles is enough. You could tighten up these commutators a little bit, make this gap a little bit smaller, and then by bending one of the ears out, like what I mean is, use super glue, grab one of these edges here and kind of kick it out at an angle. Am I explaining that well? And it'll minimize the arc, the shorting.
Or even you could just use super glue, just put it on the top of it so it insulates it, so that
Yeah, but you're going to make your gap bigger though. I don't know. You can experiment with that. Put that in the comments, and that would be appreciated. So let's crank this bad boy up and see what sort of speed we're getting. What are you getting?
680, 90.
That's crazy. Is it that fast?
700, yeah.
That's very, very fast.
It's fluctuating.
It seems very fast.
Dropping.
Watch this, we crank up the voltage. Okay, now
We're up to 1,000.
yeah, our power supply is clicking like a railroad. That is badass.
We're about 900 out there now.
God, you'd turn a propeller with that, wouldn't you?
Yeah.
All right, pick up your trophy there. You can take that home with you. All right. Nice job. Thanks, Jacob.